Hi, this is Malama. Today I would like to touch upon a most general non-backtracking shift reduce parser called LR parser. Let us see the diagrammatic representation of the LR parser. It is basically consisting of three parts. The first one is input buffer, second one is stack, and third one is the parsing table. Input buffer contains the string that we wish to parse and followed by the end marker $. And stack is used to store the states of the LR0 automata. Assume that S of M is on top of the stack. And the parsing table, which has two parts, one is action and one more is go to, and this everything is controlled by the controlling unit known as the LR parser program. It is also known as the driver program. This driver program reads the current input symbol and the symbol which is on top of the stack and consult the action part of the table, and accordingly it produces the output. If the final output of the LR parser is, if the string W that is present in the input buffer is belonging to L of G, then it produces rightmost derivation in reverse, otherwise an error indication. Today we'll see in detail how to construct parsing table known as SLR parsing table. And in LR parser, this driver program is common for all the LR parsers. The differing part is only the contents of action and go to part of the table. Here there are three types of table. One is SLR parsing table, CLR parsing table, and LALR parsing table. If the table is constructed by using LR0 items, then corresponding table is known as SLR parsing table. If the table is constructed by using LR1 items, then the corresponding table is known as canonical LR parsing table. If the table is constructed by using once again LR0 items with the look ahead symbol, then the table is known as LALR parsing table. If the driver program is using SLR parsing table, then the corresponding program is known as SLR program or SLR parser. If the parser is using CLR parsing table for parsing decisions, then parser is known as CLR parser. If the table is using LALR parsing table, then the corresponding parser is known as LALR parser. Action part of the table takes the two components. One is the I, this is the state, and A is either terminal of the given grammar G, and even it could be $, the end marker of the string that is present in the input buffer. And go to part of the table, I, A. A is the non-terminal O here, and I is the state. I mean the action part of the table is existing only for the terminal of the given grammar G, and go to part of the table is only for the non-terminals of the given grammar G. Now let us see how to construct SLR parsing table, that is it's using LR0 items. So the very first step in constructing SLR parsing table is to first we need to find out canonical collection of sets of LR0 items, say I0 through I of n. And the input for this is the augmented grammar G dash. And second step is to how to construct the action part of the parsing table. The basic entries within the action part of the table are shift, second one is reduce, and third one is accept, and fourth one is error. Accordingly, we have three different steps within action part of the table. The first one is for the shift entries, second one is for the reduce entries, and third one is for the accept entries. And error entries are common to both action part of the table and go to part of the table. That's why we took it commonly, that is in the fourth step. First let us see how to fill the shift entries within the action part of the table. If A2 alpha dot A beta, if this kind of item is present in I of I, then find out go to of I of I comma A. Suppose it is making the transition to I of J, then set action of I comma A to shift of J, where A should be the terminal. Next, if A to alpha dot, that is dot should be at last location. If this kind of item is present in I of I, then set action of I comma A to reduce to the production A to beta for all A which is present in follow of A, that is LHS of the production. Third one, if s dash to s dot is in I of I, then set action of I comma dollar to accept. Now let us see how to fill the go to part of the table. Go to, it is used to find out transitions in the LR0 automata from state I to state J, and it is existing only for the non-terminals of the given grammar G. If go to of I comma A equals to I of J, then set go to of I comma A2, that is I through, and capital A column to J. The entries which are not defined by rules 2 and 3 are made error. Now let us see the glimpse of the above algorithm. Shift entry. In order to find out the shift entries, we need to search for the item in any state, say I of I. That is the item wherein the symbol which is followed by dot should be the terminal, that is small a. If this kind of item is present in I of I, then set action of I comma A, that is in which state it is present, that I suppose it is present in I naught, then 0 throw, and A, the symbol which is followed by dot A, suppose this is plus, then 0 comma plus, equals to find out go to from I of A on A, suppose it is making the transition to I of J, then set action of I comma A to shift to J. So J is the next state. Reduction. Reduction is existing only for the items wherein the dot should be present at last location. Suppose this kind of item is present in I of I, then set action of I in which state this kind of item is present, say I naught, then this is 0 through, I becomes a 0, then column, number of columns are equals to each terminal, say small a, which is belongings to A, that is LHS of the production, we would like to reduce, LHS of the reducing production. Then go to part of the table. For that we need to search for the item wherein the symbol which is followed by dot should be the non-terminal. Say A, I mean suppose this kind of item B to alpha dot A beta. A is an argument for go to, and I is, suppose this kind of item is present in I of I. Suppose this is present in I0, then this is 0, and symbol which is followed by dot is say capital T, then this is T. Then just to find out go to of I, that is subscript I, comma, symbol which is followed by dot A. Suppose it is giving us a new state I of J, then set go to of I comma A to J. Now let us see an example based on the algorithm what we discussed. For this we need an LR0 automata, that is canonical collection of sets of LR0 items has to be constructed in the form of transition diagram. That transition diagram is a DFA, that is a deterministic finite automata. It is known as an LR0 automata. Action and go to part of the table. So number of roses are equals to 0 through 11, and the grammar we have taken as an arithmetic expression grammar, E to E plus T, E to E, T to T star F, T to F, F to E within the parenthesis, and F to ID. This is given grammar, and its corresponding augmented grammar is E dash to E. So total number of states are I naught through I 11. So number of roses are 12. And action part is existing only for the terminals as we have seen in the algorithm. So the possible terminals in this grammar are ID, opening parenthesis, closing parenthesis, star as well as plus. I have written in the increasing order of their priorities, that is ID plus star, opening parenthesis, closing parenthesis. Along with that, one more extra column for the end marker of the input buffer. And go to part of the table is existing for the non-terminals of G, not G dash. They are E, T and F, so totally 3 columns. Now let us see how to fill the action part of the table as well as go to part of the table. In order to fill, we need to start from the initial state of the LR0 automata, that is I naught. So in order to fill the shift entries, I need to search for the item wherein the symbol which is followed by dot should be the terminal. Yes, we have two such items in I naught. That is symbol which is followed by dot is the opening parenthesis and the symbol which is followed by dot is ID. So pick this item. It is present in I naught. So I need to find out go to of I naught comma opening parenthesis. Go to of I naught comma opening parenthesis is making the transition to I4. So now I need to set action of 0 comma opening parenthesis to shift of 4. 0 comma opening parenthesis to shift of 4. And similarly one more such item, that is ID, which is present in I naught and it is making the transition to I5 over ID. Now I need to set action of 0 comma ID to shift 5. 0 comma ID to shift 5. Next, I naught contains, that is a dot E. The symbol which is followed by dot is a non-terminal, and here also the symbol which is followed by dot is a non-terminal, that is E. It is ready for go to entry. It is present in I naught and over E it is making the transition to state I1. Now set go to of 0 comma E to 1. Go to of 0 comma E to 1. Next, T as well as T, and once again this item is ready for go to entry. Find out, it is present in I naught, so find out go to of 0 comma T, it is making the transition to I2. Now set action of 0 comma T to 2. Go to of 0 comma T to 2. Next, F, once again it is ready for go to entry. Find out go to of 0 comma F. It is making the transition to I3. So now set go to of 0 comma F to 3. 0 comma F to 3. Now I naught is done completely. Next I1. This is according to the C step of the algorithm. If this kind of item is present in IFI, yes, it is present in I1. Now set action of 1 comma dollar to accept. Action of $1 comma dollar to accept. Next, once again the symbol which is followed by dot is a terminal. It is ready for shift entry of the action part of the table. Now find out go to of 1 comma plus. It is making the transition to I6. Now set action of 1 comma plus to shift 6. 1 comma plus to shift 6. I1 is done completely. Now we'll move on to I2. I2 E to T dot. It is ready for reduction. In order to fill the reduction entries, I need two things. One is follow of all the non-terminals. It is already ready. And also I need to number for the original grammar G, not for the augmented grammar like 1, 2, 3 in sequence. And the production number E to T, which is ready for the reduction. This production number E to T is 2. Now it is present in I2, so row is I2 and the columns are equals to follow of the LHS, that is follow of E. Follow of E is dollar plus and closing parenthesis second row, and columns are plus, that is closing parenthesis and dollar. So set these fields to reduce to the production number 2. Production number 2 is E to T. Next we have one more item in I2, but which is ready for shift entries, and symbol which is followed by dot as a terminal. Now find out go to of I2 comma star. It is making the transition to I7. Now set action of 2 comma star to shift 7. 2 comma star to shift 7. I2 is done completely. Now we'll move on to I3. I3 is present over here. In I3 we have only one item which is ready for reduction, since the dot is present at last location and its production number is 4. Now set, that is look at third row. Yes, it is ready, and find out follow of T. Follow of T is dollar plus closing parenthesis and dollar, that is plus closing parenthesis dollar and star. Now set all these fields to reduce to the production number 4, that is T to F. I3 is done. Now we'll move on to I4. I4, the first item is ready for go to since symbol which is followed by dot as a non-terminal. Now find out go to of 4 comma E. It is making the transition to I8. Now set go to of 4 comma E to 8. Go to of 4 comma E to 8. Once again the second one is both are E and here T, both are E. Both are ready for go to. Now find out go to of 4 comma T. It is making the transition to I2. Now set go to of 4 comma T to 2. 4 comma T to 2. And next item F, it is present in I4. Find out go to of 4 comma F. It is making the transition to I3. Now set go to of 4 comma F to 3. 4 comma F to 3. I4 is done completely. Now we'll move on to I5. I5 we have only one item which is ready for reduction since the dot is present at last location, and production number of F to ID is 6 and follow of F is dollar plus closing parenthesis and dollar closing parenthesis and star. Now I need to pick fifth row. So now I need to set all these columns, that is plus star closing parenthesis and dollar to reduce to the production number 6. I5 is done completely. Now we'll move on to I6. First two items are ready for go to. So find out go to of 6 comma T. They are making the transition to 9. Now set go to of 6 comma T to 9. Go to of 6 comma T to 9. Next once again I6 F. So once again it is ready for go to. So find out go to of 6 comma F to 6 comma F to 3. Go to of 6 comma F to 3. Next this is ready for shift entry of the action part of the table. Now find out go to of 6 comma ID. It is making the transition to I5. Now set action of 6 comma ID to shift 5. 6 comma ID to shift 5. I6 is done completely. Now move on to I7. It is ready for go to. That is find out go to of 7 comma F. It is making the transition to I10. Now set go to of 7 comma F to 10. 7 comma F to 10. Now this is ready for shift in I7. Next, now the symbol which is followed by dot is opening parenthesis. It is ready for shift entry of the action part of the table. Now find out go to of 7 comma opening parenthesis. 7 comma opening parenthesis is making the transition to I4. Now set action of 7 comma opening parenthesis to shift 4 as well as 7 comma action of 7 comma ID to shift 5. 7 comma ID to shift 5 and 7 comma opening parenthesis so shift 4. So I7 is done completely. Now we'll move on to I8. Now both are ready for shift entries of the action part of the table. Now find out go to of 8 comma plus. 8 comma plus is making the transition to I6. Now set action of 8 comma plus shift 6. 8 comma plus to shift 6. And similarly on a closing parenthesis it is making the transition to I11. Now set action of 8 comma closing parenthesis to shift 7. 8 comma closing parenthesis to shift 7. I8 is done completely. Now we'll move on to I9. I9, the dot is present at last location. Now the production number of E to E plus T is 1. Now set action of 9 comma the columns are equals to follow of E, that is follow of E is the dollar plus closing parenthesis. So 9 and the columns are plus closing parenthesis and dollar, set them to reduce to the production number 1, that is E to E plus T. 9th one is done. Now 10th is also ready for the reduction. Its production number is 3. Now set action of 10 comma, columns are equals to follow of T, that is dollar plus closing parenthesis star, that is set them to the reduce to the production number 3, that is R3. Now I10 is done completely. I11 once again ready for reduction. Its production number is 5, and for that I need follow of F. Follow of F is dollar plus closing parenthesis and star. So 11 comma plus star closing parenthesis and dollar, set them to reduce to the production number 5, that is F E within the closing parenthesis. Thank you.